In this video, we're going to talk about how to use chromatography and how that relates to what we have been studying in Unit 5. So first of all, there's been a crime. This is the Barbie head that Mr. Koval keeps in his classroom. There's a story behind how it got there. He used to have his students do projects on the chemistry of different types of products that are used at home, and somebody did a project on hair dye. And so they brought this Barbie in to show it, and so he ended up with it. And apparently one of the other teachers in my department has kidnapped Barbie. So it's your job to determine which one of my colleagues did this. So here's the note. You can see that this person wants $500,469,326 and all A's for their students. And we have to leave the money under the bleachers at midnight. So the ransom note appeared on Mr. Koval's desk this week, and we can analyze the ink from the pen using chromatography. I have pens from the suspects, so we can compare the ink from the suspect pens to the ink in the note. Barbie's in danger. As you can see from exhibits 1, 2, and 3, she has been gagged and they have cut her hair. That is her hair in the bag. It is really horrifying. We need to rescue Barbie quickly by determining who has her. Now here are your suspects. There's Mr. Murata with pen number 1, which is a non-permanent pen. Mr. Woodlock with pen 2, also non-permanent. Ms. Showers is pen 3. That's a permanent pen. I used a Sharpie. Dr. O is pen number 4, also non-permanent, and Mr. Littell is pen 5, which is also non-permanent. You'll need to write this down because you're going to have to figure out who done it. So if you read the instructions on the lab sheet, it tells you to draw a line about 1 centimeter from the bottom of the chromatography paper. And you can see my hand there, so you can see about how wide the strips are. It's about 1.5 inches wide. And so I drew a little line on the 2 pieces of paper about a centimeter from the bottom. And then I took each of the 5 pens and I drew a very small dot on each of the strips. And I spaced them out so they won't overlap each other. Okay, so that was step 2. And then here's a time-lapse video of the actual chromatography so you can see what happened. On the left, you have a beaker with some water in it. On the right, you have a beaker with some ethanol. You should know the formula for water, H2O. Ethanol is CH5OH. Okay, so I'm going to let you watch and see what happens. So you can see the liquid moves up the paper and carries the ink, in most of the cases, with it. The process took about 20 minutes. The ethanol has a watch glass on top to keep the vapors from escaping. That makes it go a little bit more quickly. All right, so here are the results. The strips on the left are the ones that you saw made in the video. So that's pens 1 through 5 in water on the left and in ethanol on the right in the left-hand picture. And then on the right, these are dots of the ink from the actual ransom note pen. So the suspect ink in the water and the suspect ink in the ethanol. And you're probably looking at that and trying to determine who actually committed the crime. So hold on, hold that thought, and we'll talk about it. You can come back and look at this, or you can look at it in the PowerPoint later. All right, so let's talk about how chromatography works. So we need to figure out what allows the colors to be separated out, because you can see that black ink is not just black ink. It's made of different colors of ink. And so there are different ways that there are different things that cause the compounds to move farther than others, and that's based on the attractions between the liquid, either the water or the ethanol in our case, and the colors, the different colors of the different inks that are in the black ink. And then we have number 3, which does not move at all in the water. So you can see, and then number 2 doesn't really move in the ethanol. So you can kind of see that that happens as well. So when you look, the Sharpie is the permanent pen, number 3, and it probably doesn't surprise you when you realize that, to know that that is not going to move in water, because if you've ever tried to wipe Sharpie off of something with water, you know that that won't work. So Sharpies have intermolecular forces that don't make them attracted to water. Now you can see that number 3, the Sharpie moved in ethanol, and that's because it does have forces that are attracted to ethanol. Okay, and we'll talk a little bit more about that. So the other thing is, why do the compounds travel differently in water and ethanol? So we've talked about the different types of intermolecular forces that the molecules can have. And we know that water has dipole-dipole intermolecular forces. That means it is polar. So when we say something is polar, that means it has dipole-dipole intermolecular forces. And then when we talk about something that's nonpolar, it means something without dipole-dipole intermolecular forces. And water is much more polar than ethanol. And so you can see that certain things travel better in the water because they are similar to water, so they are more polar, whereas ethanol is less polar and things don't travel quite as well. And that's why the Sharpies travel with the ethanol, because Sharpies are not polar like water, they are nonpolar, so they don't tend to dissolve in water or travel with the water in a chromatograph. And here's a nice big strip, the 5 strips, so you can see what those look like. So the differences in the mobility, the ability for those colors to move, is based on the differences in how well the compounds are attracted to each other. So the things that traveled with the water are more attracted to the water than they are to the paper. So the Sharpie's pretty attracted to the paper. The other inks are more attracted to the water. The ones that travel the whole way that the water went, all the way up to the top, just under where it says water, are the ones that are most attracted to the water. So those would be the colors that are most polar. And then with ethanol, it's less polar than water, but even less polar than the paper, so that the Sharpie is attracted to the ethanol rather than being attracted to the paper, so it moves with the ethanol. And you can see that there are different colors coming out of even the same pen. When you look at the water and the ethanol, the colors travel differently and look different, and part of that has to do with those attractions. And the way that we understand chromatography is, again, we had to understand the intermolecular forces, those attracted forces between molecules. And then in order to understand that, we had to learn the shapes of the molecules, or the molecular geometry. And in order to understand the shapes of molecules, we had to understand how the atoms in a molecule are arranged. So we had to draw the Lewis structures, and that helps us figure out how the different attractions form between different types of molecules. If you have any questions, check in with me and let me know. Have a great day.